Okay, so we're going to be having a look at circles, area and circumference. But the first thing we need to be have a look at is circles. So some definitions on circles. So let's draw a circle down first. Now the first thing we probably need is this here, which is called the radius. That's from the centre to the edge. We've got all the way across, which we know is a diameter from one side to the other. We also know that if we have a line touching like this is called a tangent, like so. And we also have, I'm going to highlight this part here. I'm going to be coming back to this one later. If we have a section which is cut off from the centre, this is called a sector. We also have, I'm going to do this in a slightly different colour, that there is called a chord, and I'm going to highlight this one in a different colour. This here is called a segment. That's pretty much everything you'll need to know for a circle. You will need to know all of those. They do get asked those definitions every now and again. So get those ones down. Now the thing that we do need to know with this are the two formulas. So we need to know the area of a circle. Does everybody know what the area of a circle is? Yeah, so that area is equal to pi r squared. Yes, spot on. Does anybody know? Oh, I'll tell you what I haven't wrote on here, which I do need. We also need this one's quite important actually, because we do need this one. We need the circumference, which is going to be the distance all the way around. This is called the circumference. This is called the circumference. Does anybody know what the formula for circumference is? Yeah, that's exactly it. Yeah, so the area circumference, and there's actually two formulas for this. So your circumference is equal to pi times by d. So pi times by your diameter, or as somebody said, 2 times pi times the radius. 2 pi r. And these are the ones we're going to be using today. They're quite straightforward, these, but they do get trickier towards the end, as always. So hopefully you got all those down. I'll give you a second. Okay, let's move on. Let's have a go at these questions then. Example 1, example 2. I'll do both of these examples. They're quite straightforward. There is one thing that I'm going to suggest, and this is not just for circles. This is for like semicircles, or if we're doing Other things like cones or cylinders or spheres. The thing that is always important here is just making sure you know which one's which. So you'll notice that these questions look very similar. They're both asking for the area, but they're ever so slightly different. And the reason they're different is because the left-hand side one's been given the radius, and the right-hand side one has been given the diameter. So first of all, with all of these questions, I think it's worth writing down what the radius and the diameter are to get you started. Get these in your red book. So in this one here, my radius is 12 millimeters. And my diameter in this would be equal to 24. Now I know that we don't need that, but it's a good habit to get into. We know that the formula for the area of a circle is pi r squared. And we know that the radius is 12, so this is pi times by 12 squared. Now there's two ways to do this. There's the non-calculator method and the calculator method. Now, it's worth noting how to get pi up on your calculator. So pi is the little button which is above the times 10 to the x. So you've got to press two things. You've got to press shift plus the next one, and it's this button here. It's times by 10 to the x. And there's a little tiny pi above there, so you need to press that to get pi. There, like so. So shift pi times by, well, we can do that on our heads. 12 squared is equal to 144. If you're doing this non-calculator method, sometimes they'll ask for it in terms of pi. So in terms of pi, this would be 144 pi centimeters squared, because it's still area. Just because it's in terms of pi doesn't mean it's not in terms of centimeters squared. So this would here would be the non-calculator technique. But then if we want to change that to our calculator, then we press the button which looks like this. There's a button which is S to D, like so. So I do 144 pi, 144, shift pi, and then press the S to D. Now this is saying it wants it to one decimal place. So my area is equal to 452.38934 ... Now it's because it wants it to one decimal place. I'm going to put that there. This is the one that I'm looking at, that 8, which means I'm going to round up. So it's going to be 452.4 millimeters squared. Brilliant. So get that one down in your red book. Do you want to have a go at that one? I have got like another set of questions here which are similar, but I don't think we need more than one of those, I think. Can everybody have a go at that one on the right themselves? Just make sure you've got that first part right. In this case here, the diameter that you have here is 3 meters. And your radius is equal to 1.5. That's your starting point here. Okay? That's ever so slightly different. Have a go at that one yourself and type your answers into the Brilliant. Brilliant, brilliant. Super. So I'm going to quickly go through this. Area is equal to pi r squared. So area is equal to pi times by 1.5 squared. So shift pi times 1.5 all squared is equal to, we want it to one decimal place, so it's 7.1 meters squared. Make sure you're getting those units right. Well done to everyone who's done that one. Now we did have 2 here to have a go at. I'm not going to do those 2 because I think we're alright with those. They're just the same as the ones we've done. I am going to have a look at this one. So let's get this one down here as example 2. So this is ever so slightly different. And the reason for that is that this one here is a semicircle. So with this one here, same as always, the first thing you need to know is that, see this? This here is our diameter. Okay, this here is our diameter. So my diameter is equal to 2 meters, which means that my radius is going to be half of that, which is 1 meter. Always get into the habit of doing that one. So, because this is a semicircle, we know we're just cutting the area in half. Now, that doesn't always work when we're doing things like perimeter of these, but we'll talk about that a little bit later. So let's just make it really clear to the examiner. A full circle is equal to pi r squared. In this case, that's going to be equal to pi times by 1 squared, which is equal to 3.14 centimeters squared. That there is for a full circle, but we don't want the full circle. We want a semicircle. So with a semicircle, we need to divide that by 2. So semicircle area is equal to 3.14. 3.14 divided by 2, which is equal to 1.57 centimeters. Ooh, what a mistake have I made there? It says it wants it to 1 decimal place, so that's going to be 1.6. And that's meters squared. I nearly put centimeters. I did put centimeters here. Be careful with that. You'll lose marks for that. So there we go. 1.6 meters squared. Nice and easy. Get that one down in your notes. And then once you've done that, have a go at the one on the right. Brilliant for those who've done it. Remember to always write down. Get into the habit of that. Diameter is equal to 8. My radius in this case is going to be equal to 4 millimeters. So if I want the area of this, you can do it all in one. If you want pi r squared divided by 2, which is equal to pi times by 4 squared, all divided by 2. Do it all in one if you want, which is to 1 decimal place is 25.1 millimeters squared. Be careful, let's just get into the habit. As a, if we were to do this as in terms of pi, it'd be 16 pi divided by 2, which is 8 pi. That's non-calculator. Just getting into the good habits. Brilliant. Okay, so we've done those two. So this one's a little bit different. This is example 4, is it now? Example 4. And the difference with this one is that they're asking you to find the circumference of the circle. And we know that the circumference is the distance all the way around. Again, as always, I'm going to write down the values I know. So in this case, the radius is equal to 3 centimeters. The diameter is equal to 6 centimeters. It doesn't matter which formula you use. We'll go back up to the top to check. What's the formula for circumference? Well, the formula for circumference I wrote down was this one here, pi times d. So pi times d there. So pi times d or 2 pi r, it doesn't matter which one you use. My circumference is equal to pi times by d, which is the diameter. So my circumference of this one is equal to pi times by 6, which in a non-calculator is going to be 6 pi. My units on that are centimetre. I'm going to ask a question. Why are my units on this one centimetres and not centimetres squared? That's exactly it. Yeah. So it's because it's not the area, it's the distance around. Okay, it's like the perimeter, isn't it? Yeah. So we'll write it down because it does ask it to one decimal place. So 6 pi is equal to 18 points. So the full answer C is equal to 18.8495 dot dot dot. So to one decimal place, that's going to be equal to 18.8 centimeters. Have a go at that one on the right hand side. Have a quick go at that one on the right hand side. Good spot. I did know that. Why are they? So somebody said here that they are the same question. Why are they the same question? Tell me why they look different. One's 3 and one's 6. Why are they the same though? Go on. Brilliant. Yeah. So with that one, they've got the same. So this one here, the radius is 3. The radius of this one on the right is also 3, isn't it? Okay. They're just giving it you. They've given you the diameter on the right, and they're giving you the radius on the left. So they're exactly the same. Spot on. So both 18.8. Brilliant. Now let's step it up a little bit. Now, okay. We've done the basics. We're going to move up a little section now. So a circle has. Get this one down. This is example 5. A circle has an area of 19 meters squared. Calculate the radius of the circle. What's different about this one? What's different about this one? What am I trying to find in this one? Alright, so the difference with this one is we're not trying to find the area this time. We've got to work backwards to find out the radius. So this is where we think about those 4 steps that we spoke about, isn't it? So it might be worth writing them down again, actually. The 4 steps which we spoke about when working backwards, and this is always going to come up, okay? These 4 steps are to, number 1, write the formula. Number 2, sub in. Number 3 was to simplify. And number 4 was to solve working backwards. So because now because we are working backwards now, we need to be thinking about those 4 steps. So we need to write the formula, substitute in, simplify, and then solve working backwards. So let's do each of those steps. The first thing I need to do is I'm dealing with the area, so I need to write down what the formula for the area of a circle is. So my area of a circle is equal to pi r squared. I know that the area is equal to 19, and I know that, well, it's the radius actually, I don't know. So the only thing I can sub in now is 19 is equal to pi r squared. Now remember, we're trying to find out what the radius is. So to do that, we need to work backwards. Now we need to get rid of that pi before we get rid of that squared. And the reason for that is because if I was doing this forward, you'd need to square first and then times by pi. So the first thing I need to do is to divide both sides by pi. So divide by pi, divide by pi. So on your calculator, 19 divided by shift pi is equal to 6.048 is equal to the radius squared. And then we need to get rid of that squared by square rooting both sides. So square root, square root. So shift square root, my answer. Which is equal to 2.45. So R is equal to, the full length one is 2.4592, continuing. So rounding that is equal to, R is equal to 2.5 meters. Okay, have a go at that question on the right-hand side. Have a go at the question on the right-hand side. So have a go at that question on the right-hand side. Some people have got it already. Good, good, good. So we know that R is equal to 6.6 millimeters in this case. Everybody alright with that? Brilliant, let's move on to something harder. Pop your hand up if you're alright with that. Just keep your hand up, don't put it down yet. Keep your hand up if you're okay. Brilliant. So let's move on. So this one here, it's very similar, to be honest. It's not actually that much harder. So this one here is example 6. Get this one down in your notes. Example 6. A circle has circumference now of 89 millimeters. Find the radius of the circle. I actually think this one's easier if you know what the formula is, but people get confused with using the formula. So with this one here, we're trying to find out what the radius is. So we know that the formula for the circumference is equal to pi times by d. And the thing that I know is that the circumference is equal to 89 millimeters. So I know that 89 is equal to pi times by d, which is d pi, or pi d, I should probably say. So to find out what my diameter is, I need to divide both sides by pi, divide by pi, divide by pi. So 89 divided by shift pi is equal to 28.32 is equal to my diameter. But I haven't finished here because they're not asking for the diameter, they're asking for the radius. So how do I find my radius then? If I know what the diameter is, we need to divide by 2. Yeah, good. So my diameter is this, so I need to divide by 2 to find my radius. So divided by 2. So that's, the radius would be equal to 14.1647, continuing on. So to round this, I'm going to put one line after here, and that's going to be equal to r is equal to 14.2. Brilliant. Have a little go at that one on the right. Have a little go at that one on the right. Now I can see 2 people have put answers, both different, both wrong actually. People are flying through this, and I know they've got it right. There's only one right answer there. Right, okay, I'm just going to quickly do this. Everyone's getting the right number, but their rounding is wrong. And this is really, really important, okay? So I know that my circumference is equal to pi times by d. My circumference here was this one. So 100 is equal to pi d. Divide both sides by pi, that's fine. So 113 divided by pi is equal to 35.969, continuing on, is equal to d. I'll divide that by 2, which gives me my radius is equal to 17.984, continuing on. Okay? And it's the rounding that everybody's getting wrong here. I think there's only one person who's got this right. So I'm rounding to 1 decimal place, which is there. The 8, this 8 here means that the 9 is rounding up. Now the round obviously rounds up to 10, which means this whole number needs to go to 18. But because it's a 1 decimal place, you need to write down 18.0. That is correct to 1 decimal place. Okay? Make sure you're not making that mistake. You would lose a mark for that. If it says to 1 decimal place, it must be to 1 decimal place. Okay, so let's have a look at this one now. Now this is a typical GCSE style question. We've got a few of these to have a go at, and then we're going to have a go at some by yourself. So Parvinder has a bicycle. Each wheel has a diameter of 65.5 centimeters. Okay. On one journey, each wheel is rotated 3,509 times. Calculate the distance that Parvinder has travelled. So, does anybody want to make any suggestions how to do this? We're trying to find out the distance travelled, and we know that it is gone round. So, you are right in saying that we need to find the circumference. Okay, you were right in saying that we need to find the circumference. The circumference tells you the distance all the way around the wheel. So if the wheels turn around 3,509 times, then we need to times by the 3,509. However, it doesn't matter that there's two wheels on a bike. It's only turning around like this, okay? Just because you turn twice doesn't mean you're going twice the distance. They're turning simultaneously. So you're right. What we need to do here is you need to find out what the circumference is first of all. Now we know that the circumference is equal to pi times by diameter, which in this case is equal to pi times by 65.5. Let's do that on our calculator. 4 marks for this, and it was on the higher paper. So shift pi times by 65.5. So one rotation would be equal to, give it in kilometers. So I'm gonna keep loads and loads and loads and loads of decimals here. So I'm just gonna keep the amount of decimals. So one rotation would be 205 centimeters, 0.77431. So this here, and let's make it really clear, this here is one rotation. So if I wanted to do 3,509 rotations, I need to times this. So, So 205.77431 times by 3,509 times by 3,509, which is equal to 2,062.08. Now don't forget this is in centimeters, and they said that they want it in meters. Kilometers. So let's convert it to meters first of all by dividing by 100. So if I divide this by 100, it's going to be 7,220.60 meters. And then if I want to turn it into kilometers, I need to divide by 1,000, which is going to be 7.2 kilometers. Brilliant. Super. So get that down in your notes. We've got one more exam question to go through, I think. Might be two, actually. And then we're going to have a go at some ourselves. Okay, so let's have a look. This will be the last question we have a look at. So this here actually came up in the higher paper in 2006. Question 6 on it was. Now, the thing here with this one, zoom in here, we're trying to find the shaded area, so this area of the bottom. Now, the first thing people might say is, well, I don't know any parts of that circle. However, we know, because it's touching both sides, that this is also 8 centimetres here. Get this one down in your notes, please. So this here is also 8 centimetres. We know that. So to find out the area of that shaded, it's going to be the area of this, hey, keep touching the screen, the area of this rectangle here, take away the area of this semicircle there. So we need to find out the area of the rectangle. That's quite easy. And then we also need to work out the area of that semicircle. We need taking that semicircle away. So let's just do that now then. The area of the rectangle, to make it nice and clear to the examiner, is equal to length times width, which is 8 times by 12. 8 times by 12 is equal to 96 centimetres squared. The area of this semicircle, well, I know that this circle, let's just draw a little circle. I know that the diameter in this circle is equal to 8 centimetres. And I know that the radius would be half of that, which is 4 centimetres. For the semicircle, we know that it's pi r squared divided by 2. So that's pi times by 4 squared, all divided by 2. So shift pi times by 4 squared, 16 pi, divided by 2 is going to be 8 pi. Let's write that as a decimal. Do it to one decimal place. Divided by 2. So that's going to be equal to 25.1 centimetres squared. So the last little part, this part here is the area of the rectangle. This part here is the area of that semicircle. So the shaded is equal to the area of the rectangle minus the area of the semicircle, which is equal to 96 minus 25.1. 96 minus 25.1 is equal to 70.9 centimetres squared. Nice and straightforward. Okay. Pop your hand up if you've got that done. Pop your hand up if you're happy with that. Okay. So, if you are catching up with this at home later in the day, these are the questions for you to have a go at. So pause now and have a little go at these questions. There's also some more as well. So if you are catching up, pause and have a go at these questions. And there's your answers to those ones. So